Okay, these are the 6-3 notes. You should have your textbooks open to page 348. I would suggest having a calculator next to you, and we're going to get started. So we've been talking about how to deal with systems of equations, and a system of equations is when you have two or more equations put together, and they just sit right on top of each other. So if you're looking for an example, go to page 348, example 1. They give you two equations, and we've also been talking about how two equations can have a solution, and a solution is an a set of x and y values that can be plugged into both of those equations and make them both true. Now, in section 6.1, we learned that we could solve these systems by graphing, and where they intersect, we find their solution. In section 6.2, we used substitution in order to solve them. Today, we're going to start talking about another way to solve them, and it's my personal favorite, where you use elimination. And elimination in math means the exact same thing as it does in real life, where it is using something to get rid of one of your variables. So we're going to use addition and subtraction, and then a little bit later on we're going to use multiplication and division as well to eliminate one of your variables, and then once you do that, you can use substitution to solve. So elimination, we're going to say the process of eliminating a variable in order to solve a system by substitution. Okay, so there are a few steps. The first step is write the system so that the like terms with the same or opposite coefficients are aligned. I'll show you what that means in just a second. The second one is to add or subtract the equations to eliminate one variable. 3, solve the resulting equation. 4, substitute the value from step 3 into one of the equations to solve for another variable. 5, write the solution as an ordered pair. That's a lot of steps, but when we start doing examples, it's going to make a lot more sense. On the next page, we see our first example. We have 4x plus 6y equals 32, and then 3x minus 6y equals 3. So the very first step tells us to make sure that we have terms that have the same coefficient and that they are aligned. Now, taking a look at this, I have 4x and 3x. They do not have the same coefficient. Go to the next set of terms. We have 6y and 6y. Those do have the same coefficient, and so when they say make sure they're aligned, it means they're on top of each other. So this one and this one are sitting on top of each other. Now, we're going to follow the next step, which if you look, add or subtract the equations to eliminate one variable. Now, taking a look, if I want to eliminate this one, because the one with the same coefficient, I want to eliminate y, will I add or subtract these? If I take positive 6y and I add a negative 6y, I end up with 0y, which is just 0. Therefore, it's eliminated. So when they have opposite signs, you should add. Now, let's pretend that they were both positive 6y. So if this had been plus 6y and plus 6y, then they have the same sign, and you should subtract in order to eliminate them, because you would have positive 6y minus positive 6y, which gives you 0y, and therefore you're eliminating the y's. So this one was positive, or their opposite sign, so we're going to add. So I'm going to put the bottom equation in parentheses and put an addition sign out here. If I was subtracting, I would still put that parentheses and put the negative sign out front, or the subtraction sign. So you just start with your x's, and we're adding them. So I have positive 4x plus a positive 3x, which is positive 7x. Now I have positive 6y plus a negative 6y, which is just positive or plus 0y, equals, and then 32 plus 3. Which is 35. Now I know that 0y is just 0 and it can just be crossed out. Now I have 7x equals 35. I can solve that by using division. Divide each side by 7 and I get x equals 5. So I just solved for one of my variables. The next step says use substitution to solve for your other variable. We have an x value, we need to find a y value. I just have to sub that 5 in somewhere. I'm going to choose the top equation. It doesn't matter which one you choose. So I'm going to say 4 times 5, because it's 4x, plus 6y equals 32. So 20 plus 6y equals 32. Subtract 20 from both sides. I'm left with 6y equals 12. Divide each side by 6, and I get y equals positive 2. So now I have my x and my y value, and I can write them as an ordered pair. Make sure you write the x value first. So there's a little bit more thinking here. The biggest thing is if you are adding them, you just add straight up and down. If you are subtracting them, that means that these signs have to change, and it would have been 4 minus 3 and 6 plus positive 6, because a negative times a negative makes positive. And then if we would have subtracted here instead. I don't want you to get too stressed out about the subtraction, because I believe we're going to do an example of that later on in our notes. It's not as tricky as it sounds, but you do have to think about what you're doing. So go ahead and turn to the next page. I want you to try this one on your own. Keep in mind the 4's are aligned and they're opposites, so you should add here. I'm going to keep going, so you should pause the video and then come back to it when you have finished doing the example. Okay, so I'm going to add them because my 4's are aligned. And I have a negative 4x plus a positive 4x. That gives me 0x. Then I have a positive 3y plus a negative 5y. Gives me negative 2y. Equals negative 3 plus positive 5 gives me positive 2. The 0x's just cancel because it's 0. And so I'm left with negative 2y equals 2. Divide each side by negative 2. I get y equals negative 1. So now I have my y value. I'm going to plug it in. I'm going to plug it into the second equation because it has a positive 4x. So I'm going to say 4x minus 5 times negative 1 equals 5. I get 4x plus 5 equals 5. Subtract the 5's. I get 4x equals 0. Divide by 4. X equals 0. So my ordered pair is 0, negative 1. And that's my solution for that system of equations. Go ahead and turn to the next page. We are going to talk about this one. Take a look. We have 4y plus 3x equals 22, and then 3x minus 4y equals 14. Biggest thing is I have my x's and y's in different places. In the first one, the y comes first and the x comes second. In the bottom one, the x comes first and the y comes second. We know that we have to have those coefficients and like terms aligned. So I'm going to rewrite the first equation. So I'm going to have positive 3x plus 4y equals 22. And then I'm going to just write the second equation as it is. Okay. So now I have my 3x's and my 4y's aligned. So from the previous examples, we could say, well, the 4 and the negative 4 are opposites, so I could add this. But I'm going to try something different so that you can see another kind of way to do this. I also have positive 3 and positive 3 over here. So we know that they have the same sign, so I'm going to just try a subtraction one so you can see an example of that. So in this case, I'm saying that I'm going to try to eliminate the x's, and they're both positive, so I have to subtract. So do your parentheses with your subtraction sign out front, and I'm going to say 3x minus 3x. That gives me 0x. Then I have positive 4y minus a negative 4y. Now when I subtract a negative, it's the same thing as adding a positive. So I'm saying 4y plus 4y is 8y, positive 8y, equals, and then 22 minus a positive 14 is 8. So now I know that my 0x's cancel. I have 8y equals 8. Divide each side by 8. Y equals 1. Go ahead and plug that into any equation. I'm going to go with the top one. So I'm going to say 4 times 1 plus 3x equals 22. 4 plus 3x equals 22. Subtract the 4. 3x equals 18. Divide by 3. X equals 6. So my ordered pair is 6, 1. Turn to the next page. Sometimes they're not going to give you the actual equations. They're going to give you the sentences, and then you have to write the system and then solve it. So let's go ahead and try this one. The first one starts with -3 times a number. So I'm going to say that one number is x. So -3x plus 5 times another number. I'm going to let that another number be y. So 5y is -11. So we're done with the first system, our first equation. The next one is 3 times the first number, so 3 times x, plus 7 times the other number, so 7 times y, equals -1. So those kind of are a little bit tricky. You just have to go slow. Make sure you're writing everything that you're reading down, and then you'll have your system and you can start solving. So in this case, my x's are aligned and they have the same coefficient. They are opposite signs, however, so I'm going to add. So I have -3x plus +3x gives me 0x. 5y plus 7y gives me 12y equals -11 plus -1 is -12. So I get 12y equals -12. Divide each side by 12. Y equals -1. Then go ahead and plug it in. I'm going to go with the second one because it's all positives. So 3x plus 7 times -1 equals -1. 3x minus 7 equals -1. Add the 7. 3x equals 6. Divide each side by 3. X equals 2. And I have an ordered pair of 2, -1. Don't forget that the x coordinate has to come first. So that's how we do those. There's another example on the next page. I want you to try that one by yourself. When you're finished, come back to the video because I'm going to keep going. So I have the sum of two numbers. So I'm going to say first number is x and second is y. So x plus y, because it's sums, equals -10. And then -3 times the first number, so -3x, minus the second number, so just y, equals 2. So now I have my system of equations. I noticed that I could put ones in front of all of them that don't have coefficients. And now I have 1x and -3x. Those ones don't match up, so I can't eliminate those just yet. And then I have 1y and -1y. Those ones do match up, so I'm going to eliminate the y's. They have opposite signs, so I'm going to add. I get 1x plus a -3x gives me -2x. 1y plus a -1y gives me 0y. -10 plus 2 gives me -8. So I have -2x equals -8. Divide each side by -2. X equals +4. Then just substitute into one of the equations. I'm going to go with the top one because it's positives. And I'm going to say 1 times 4 plus 1y equals -10. So I get 4 plus y equals -10. Subtract the 4, y equals -14. My ordered pair is 4, -14. All right, turn to the next page. There's one more example that I want you to try on your own. Pause the video, come back to it when you're finished. So, first thing I have to do, rearrange some of these things. Over here I have T and R, and then I have R and T. That doesn't match up. I'm going to rearrange the second one. So I'm going to leave the first one as 2T plus 5R equals 6. And I'm going to write the second one as 2T plus 9R equals 22. The two T's match up, but they are the same sign, so I have to subtract. So write out your parentheses and subtract. 2T minus 2T is 0T. 5R minus 5R is -4R. 6 minus 22 is negative 16. So these go away. I'm left with negative 4r equals negative 16. Divide each side by negative 4. Gives me a positive 4. Then I'm going to substitute in. I'm just going to choose the top one. They're all positive, so it doesn't really matter. So I have 2t plus 5 times 4 equals 6. 2t equals 20 plus 20 equals 6. Subtract the 20. 2t equals negative 14. Divide by 2. T equals negative 7. So my ordered pair is 4, negative 7. Here's one more example. Go ahead and try it on your own. Come back to the video when you're ready. So right away when I can look at these, I can see that the 8b is aligned and they have the same sign. So I'm going to subtract. So 8b minus 8b is 0b. 3c minus 7c is negative 4c. 11 minus 7 equals 4. So now my b's go away because they're 0. Negative 4c equals 4. Divide each side by negative 4. C equals negative 1. Plug it in. I'm going to just go with the top one. I have 8b plus 3 times negative 1 equals 11. 8b minus 3 equals 11. Add the 3. 8b equals 14. Divide by 8. B equals 7 over 4. So then go ahead and plug that into one of your equations. I wanted to double check my math here and make sure why we're having fractions. So my 8b's cancel. Negative 4, 4. C equals negative 1. Oh, that makes sense. Okay, so we're going to have to deal with our fractions. So we have 8 times 7 over 4. 7 over 4. Oh, we've already solved. We have C and we have B. So my ordered pair is 7 over 4 and negative 1. Got ahead of myself. So now we have an example of what one of our word problems might take a look like. And the word problem reads, Cheryl and Jackie work at an ice cream shop. Cheryl earns $8.50 per hour and Jackie earns $7.50 per hour. During a typical week, Cheryl and Jackie earn $299.50 together, which means that their paychecks combined equals $299.50. One week, Jackie doubles her work hours and the girls earn $412. How many hours a week does each girl work? So we're going to start by adding up what they typically would earn in a week. And let's say we have $8.50 for every hour that Jackie typically works. And I'm going to give X to Jackie. Okay? And if we add that to the $7.50 Y, and I'm going to let Y be how much, I'm sorry, X should have been Cheryl. And Y was Jackie. I know that if she makes this much money in a week and Jackie makes this much money in a week, if I add them together, typically they should get $299.50. There's one equation for us. Now, if I have the other one, they're saying Jackie doubles her hours. So I'm going to take 2 times the $850X, because she's working twice as much, so she's earning twice as much money, and add it to that $750. This is Cheryl. I keep saying, oh, this is wrong. I'm sorry. Erase that one. Jackie doubles her work hours. So Cheryl stays the same at $8.50 an hour, plus 2 times the $750, because Jackie is the one that doubled her hours. And that's going to give us the $412. Now we have a system of equations that we can start solving. First thing I'm going to do is simplify this with the 2. And so I have my first equation, 850x plus 750y equals 299.50. And then I have my 850x plus 15y, 750 times 2 is 15, equals 412. Now I have a system of equations and I can start adding and subtracting. So we're eliminating, but I know that I have two 850s here. They're both positive, so I'm going to end up subtracting. And so I get 850 minus 850, that's going to give me 0. Plus, now 750 minus positive 15y gives me a negative 750y equals 299.50 minus 412. And that gives me negative 112.50. So if I simplify this even further, I get negative 750y equals negative 112.50. Divide by the negative 750, and I get y equals 15. Now remember, y is Jackie's hours. Now I can go back and I can find out what Cheryl works in a week. So I'm going to go back up here and I'm going to say 850 times Cheryl's hours plus 750 times the 15 hours that Jackie works is going to give me 299.50. 750 times 15 gives me 112.50 equals 299.50. Subtract that 112.50. And I get 187. Even. Divide by 850. And x is 22 hours for Cheryl. Okay, and since it's a real world problem, you don't have to write it as an ordered pair. You can, but it doesn't really need to be there. I just wanted to know how many hours each girl typically works. So I'm going to have you turn the page. There's one more story problem. I want you to try it on your own. I'm going to keep going, so you should pause the video and come back to it when you're ready. Tamara and Adelina are throwing a birthday party for their friend. Tamara invites 5 fewer friends than Adelina. Together, they invited 47 guests. So, how many guests did each girl invite? So we're going to say T equals number Tamara invited. And I'm going to let A be the number Adelina invited. Okay, let's start with the second part first. Together they invited 47 guests. So the number that Tamara invited plus the number that Adelina invited is going to give me 47 guests. Now we know that Tamara invited 5 fewer friends than Adelina. So if I take Adelina's friends and subtract the 5, that's going to give me how many Tamara invited. So I have to do some rearranging there because this one doesn't quite work because I don't have anything that lines up. So I'm going to take that one and I'm going to manipulate it a little bit. I have A minus 5 equals T. This top one has A and T on the same side. So I'm going to subtract the T and I get A minus T minus 5 equals 0. I'm going to put the 5 on the other side and I get A minus T equals positive 5. Now, in my first one, I have T and then A, but I can switch it around. I can make the first one be A plus T equals 47. And now I have A minus T equals 5. Now, there's a lot of different ways that you could have set up your systems of equations. As long as you're getting something similar to this, it's okay. There's a lot of different ways that you could have set these up. So now, I have these lined up. I'm going to go with these ones since they're opposite, and I'm going to add since they're opposite. So I have 2A, these cancel, equals 52. Divide by 2, A equals 26. So Adelina invited 27 guests. Now, I just have to plug it back in, and I'm going to say a minus the 26 equals, a minus 5 equals t. But I know what a is. It's 26. So I have 26 minus 5 equals t. 21 equals t, which is the number of guests invited by Tamara. Okay? So Tamara invited 21, Adelina invited 26, and that's all we needed to know. If you have any questions, make sure you let me know. You should take a look at the homework. I will see you tomorrow in class.